We'd like to welcome everyone to Serverless Deployment Pipeline using OSS, Packer, and Terraform. Today it's going to be with Tuhin, Sharma, and Mayakrishnan, Chakkarapani. I'm going to go ahead and turn the time over to you guys.
Thanks, Andrea. Hello, everyone. Good afternoon. Thanks for joining this session. I am Mayakrishnan Chakkarapani, Director of Engineering at Salesforce. With me, I have Tuhin Sharma, Principal Engineer at Salesforce. Before I dive into the topic, I want to share something interesting. Today is Thursday, and Thursdays are special days for all of our Salesforce developers. It is called No Interruption Thursdays, in short form NIT. Why NIT is special for all the Salesforce developers? Because every Thursday, during these No Interruption Thursdays, all the Salesforce developers can work from home, and they've been empowered to have no meetings, including no scrums, no one-on-ones, no face-to-face meetings, no even group gatherings. And they are free to limit emails and phones on that day, so that they can purely focus on their development and deliver code. And incidentally, this month was 10th year anniversary of this No Interruption Thursdays rollout, and it was working great. And you may ask, why Thursdays? Why not some other days? So we did an initial survey, and then Wednesdays and Thursdays came very close. And we chose Thursday because Wednesdays, it's actually have a recurring weekly patches. And so we chose Thursday as a de facto. And it worked very awesome for all our Salesforce developers. You may ask, why am I talking about No Interruption Thursdays in related to this topic today? I promise there is a correlation. So with the No Interruption Thursdays, we had 3 important learnings. One, it has improved developer productivity. And we can easily measure, because every Thursday, on the average, we have 2x code commits compared to all other working days. And secondly, we choose a right day to achieve our objectivity. So that worked out very well as well. And third and most importantly, it is scaled for 10 plus years. So today's topic is how we used Packer and Terraform, using that to build a serverless deployment architecture for our environments platform at scale. Even our solution, like No Interruption Thursday, also has 3 important outcomes for us. One, it really improves developer experience. 2, by choosing the right tool set, you can build a platform easily. And third, our solution has helped us to scale not only for the current business asks, but all the upcoming years of future business asks. So how No Interruption Thursdays had a big impact for developer productivity. Our solution also had not only the developer goals can be achieved, but also our business goals have been achieved. So I can promise next 45 minutes, we will share you how we were able to realize our goals. Let's jump in. I have a problem with the next slide. Okay, sorry about that. So before we jump in, our lawyers made us do this. Essentially, the point here is, any purchase decisions you make should be squarely based on the current existing product and services at Salesforce. Any new information you may learn should not be used for any purchase decisions. So that's kind of the call out. Thank you. Big thank you for joining in to helping us to share our implementation to you. Big kudos to the organizers of Big Mountain Data and Developers Conference to organize this event, to help us to come in these special times to share this topic in the virtualized form. Before we jump in, a little bit about myself. As I said, I worked in Salesforce about 4 years, and my expertise is all about how do we build a scalable platform from ground up. And on the personal front, generally my body warms up very slow. So I use that to my advantage in participating in marathon runs. And I love doing a relay runs. Especially the Golden Gate Relay Run is my favorite. I do that every year religiously. And also hiking is also great with my family. So I did the hiking on Pilates Club and Matterhorn, some of the best hiking spots in Switzerland. And I also love playing sports, any sports. So especially I love badminton, racquetball, and tennis. I know COVID situation is very, very difficult for all of us. So when I got stuck at home, I use that to my advantage to resume my guitar practice, which I left a long time back in college. So I started learning it, and then I'm getting good at this now. So without further ado, let's jump in. To set the context, as I said, our charter is to build a highly scalable environments platform that is being used for all of Salesforce developers at scale to help innovate faster for our customers. What we do in the environments platform is we provide a simple and repeatable environments platform that deliver stable environments for all the Salesforce engineers across all the targeted environments. And also the platform should be extensible, scalable, and needs to evolve for not only the current needs, but also the future demands across multiple substrates. How we do it? So Salesforce engineers will use environments platform to provide a combination of services that they want to test and build and integrate in a particular target representation. Now, they also have ability to customize what code versions that goes into individual services, and they can also provide a way to integrate that. And important challenge here in the platform is how do you validate this combination of services to work not only functionally, but also in the combination works for the target representation. And that's a huge portion of our challenge. So I'm going to talk about next is artifact validation service. Its primary goal, that service, is to test this functionality and also provide this combinatories of all this service interoperability, how you interoperate. That is very critical for Salesforce developers. So how we do that is the artifact validation service. It takes in all the code commits coming from Salesforce developers. And for every, as the code commit comes in, the artifact validation service has an array of deployment clusters that you can use that to mimic, to bring up all the set of services in the respective target representation. And then we will use the slew of test suites provided by the test owners, which includes sanity test, end-to-end test, any integration kind of test. And then we run them to certify which one of those code will pass in the target representation. If it's failed, we will circle back to the developer. And you may ask, what is basically the challenge here, right? And some of the challenges we had is building this in the private cloud as our journey first. So let me just deep dive. What are some of the learnings and challenges when we build this in private cloud? As you all may aware, in some form of our journey, we all leverage private cloud. And it has advantages, but it has some limitations as well. And most importantly is, how do you build your platform across multiple regions? And more importantly, how do you overcome a lot of capacity challenges? Because as your demand increases from your business, you need to provision environments in short notice. But it's not straightforward. So you may need to go through certain processes to get those procurement. And that takes weeks to months. And importantly, if you want to scale this for multiple substrate, there is no standardized tool available today in private cloud. That makes it even more harder to represent and test it at scale. And also another challenge is, how do you keep your systems available 100% time with all the patching and bug fixes that goes on day in, day out? And mutable deployments is another challenge, because you want to be repeatable to be scalable, but mutable deployments bring a lot of surprises in terms of flappers and praises and whatnot. So these are some of the capacity and infrastructure limitations will also spill over into some of the architecture of artifact validation service when we built initially. You may ask, what is the biggest problem about this system, right? Let me set some context there. So think of, we have about 7,500 Salesforce developers, and they're checking in code anywhere from 200 commits in an hour. And during the peak, during the release freeze time, that can go even more, up to 500 commits in an hour. So imagine yourself, for every code commit coming in, you really need to bring in this set of services using the target representation and test it at point of notice. Now, as I said, because of the hardware limitations and capacity limitations, we have to do some cost optimization. So what we essentially done is, we grouped this code commits into an artifact package, and we will test them in the hardware, particular test representation. And this is the only way we can scale to the incoming queue of code commits into our pool of hardware that we have available. So this worked out very well for testing purposes, but there's a limitation brought up is when this packaging of code commits into an artifact, which could be sometimes 50 or sometimes 100 or even more, depending on how many pool of servers available in our cluster at the runtime. So when this thing, particular artifact fails the validation integration test, the biggest challenge for us is, how do you quickly find out who is the suspect code commit? One way we did it is, we took that particular artifact and broken down that individual code commits, and then we do a binary searching on top of it, and still deploying them in the technical and the test representation to find out the suspect commit. And that means it's going to take more time to find a bad code commit. That means developer productivity is really not great, because they have to wait for two things, right? They have to wait for their target code to be going into, they wait for the code to go into target environment. That's one. And when this triaging happens, all the good code commits also block till we find this the suspect one to be removed, so that we can let other code commits to go through. So it's a big developer experience problem. So essentially, we all know how do we solve this, right? The need for this is to bring in one code change, one test representation, and then test it quickly, right? So essentially, that's kind of the need. So if we do that, somehow we need to scale our infrastructure to do that, then the benefits is amazing, right? From developer experience point of view. Now, when the moment code commit fails, you can quickly auto-bug developer and say, hey, you have a problem, and then you're to fix it. So that will be an awesome experience that developer get the signal quickly. And also, another advantage is, we can even confidently revert the code if you cannot reach out to the developer in the stipulated time SLA. We can even do the code reverse and then let the other good code commits to go through. So this is a kind of the, essentially it's turning this into O of n problem in the previous screen into O of 1 problem, right? Essentially that's better. We all know that, right? But these are great needs to improve developer experience. We understand that's a requirement, but we have to look beyond what we have available in our private cloud. So that is what we did. We look beyond what our limitations and then see how we can help improve this better for our developers. So as part of that, what we really did is we looked at extensively and then pick the right tool set that will not only satisfy our current requirements, but also forward-looking business requirements. So we lined up Packer, Terraform, and public cloud as our tool sets. We selectively picked up after extensive proof of concept. So what essentially this enabled us is to our vision of building this at scale, but at the same time also improve our developer experience and improve the productivity. And let's do this in a forward-looking, all the futuristic use cases that we may need to solve as a business. So I'm going to invite Tuhin to talk about how we use these tool sets and in a serverless architecture fashion that solve our business needs.
Thanks, MC. Hi, everyone. I'm Tuhin Sharma. I'm a software engineer in the environments platforms team working with MC. Let me begin with my introduction. So I'm an outdoor enthusiast. And yeah, these 7 months have been very painful. I've biked from Seattle to Portland. I think it's my biggest achievement in doing a big bike ride. I've hiked the highest peak in Greece, Mount Olympus, and I'm not a professional hiker. So this was just off my head, go through it. Another interesting thing about me, I have learned to ski and swim using YouTube videos. I thought that it's me who's the problem, so I have to fix it. A coach will only tell me what to do, but it's me who has to practice it. So I did that. I've been at Salesforce for more than 7+ years, and I've experienced its rapid pace of innovation. One of the most important things in Salesforce, the value which provides me great satisfaction is of our giving back, our 111, where it gives us an opportunity to volunteer our time, and I've used it to the full. I feel very good about getting that opportunity to volunteer in my community and outside. So this was a little bit about me. Now let's look at other serverless deployment pipeline architecture. And we'll begin with why we chose this. So why serverless? So MC brought you up the requirement that we needed an ability to scale on demand. And I'll give you some analysis around that. So with static infrastructure in our on-premise, in our private cloud, we had services running all the time. And these services weren't busy all the time. Usually our commits are not evenly distributed throughout time. They are pretty stable throughout majority of the months, but when things get closer to release and the NITs, the Thursdays, check-ins are a lot more than what happened during a normal business day. Now, by running static infrastructure, we are always running these systems, and they're not optimally utilized. So we needed a way to pick up a tech stack, pick up a platform which could be modeled on the demand we are getting from our customers. We also needed the ability to quickly iterate and switch our pipeline components to picking a tech stack that we're not tied to it, we're not married to it, and we can probably iterate quickly. And deployments are inherently asynchronous. You kick off an installation and deployment. It takes some time. Sometimes it takes 20 minutes. Sometimes it takes 25 minutes. So that by having a static infrastructure, we had a synchronous process. Step 1 after step 2 after 1, 3 after 2, and it wasn't an optimal use of that. So let me now look at let me show you our architecture. And this diagram demonstrates our architecture where we have an upstream service that generates artifacts for every change, the request we made to our partner team to help us provide that, since now we think we can scale. We use the cloud PubSub to communicate across all our service components. I want to focus on certain components here. And one of them, the first one being the Packer service. This is a service running on a managed container platform on the cloud provider, and it's running Packer. And I'll deep dive into what Packer is, how useful it is for us. And that enabled us to bake images. The second part is the control plane, the brain of this pipeline, which will orchestrate deployments using Packer, using the subsequent systems, making sure we run tests, finishing up the pipeline. And finally, the Terraform service. This is the service that uses Terraform. I'm going to deep dive into Terraform in the subsequent slides, which provides you provisioning of the resources you want for your app. So I want to take a step back here. So we were prototyping cloud providers. We were prototyping things around what would work for this use case of modeling our systems on demand. And the first answer came out was, hey, why not use cloud functions? Lambdas in AWS terminology, function as a service in the tech community. The challenge with just cloud functions or that approach is that the cloud providers provide you certain languages. For instance, in our case, Node.js and Python were the two popular languages on GCP. And that's the way you can probably encode your pipeline. What it does not provide you is an ability to run software. So we had to come up with a way where we could also have these platforms like Packer and Terraform available in that programming paradigm. And there's where we had to use managed container services. And I'm going to deep dive into that. Now let's look at Packer. So Packer is a free and open source tool from HashiCorp. It helps us create golden images for multiple platforms from a single source configuration. And we'll look at that. This process is commonly referred to as baking. A common configuration essentially is that, hey, we will define our application's metadata one way, and then we can use that same way to define, to provision resources across the board. So Packer gives us that ability. Let's look at a Packer script. Packer has a specific format, a specific JSON it parses that allows us to define roles. So roles can be you can parallel it to one-on-one with an application type on an application role or a function of an application. There are 4 sections here: variables, very similar to programming languages; reusable components to define things which you are going to use in following sections of the script. There are builders, very interesting. This has the specifics of the provider. So in this case, it's the Google Compute Engine, and we're using an N1 standard machine for machine type. What region, zone, similar for AWS, similar for other cloud providers. Provisioners, that's where we got the most amount of value. This is where we're actually installing the app. So as we walk through, now we selected a cloud resource, let's say in this case, a VM instance. Now what about the app? So provisioners allow us to run those scripts, run that installer on that resource and bake the app. So now we're baking this pie. And finally, post processors. And why I want to highlight that is that these are actions you can take once bake is complete, and they have been super useful for us. Why? Because we could send a message to Cloud PubSub to kick off our pipeline. So this gave us the ability to start our pipeline. And why it was very interesting was, since these are all asynchronous machines baking at the same time, different times, they all can be compiled together once they send the message. So now we can start a pipeline by looking at those messages. Now let's look at the service architecture. And I introduced this. It's a managed container service. This managed Packer container service provision mocks first getting the resources from the script, installing it, and it does it for any number of roles, for any number of commits that are coming in. So this managed container service enabled us to run on demand. Whenever we had many requests coming in, we could kick off multiple bakes. Whenever we had less requests coming in, we only had those number of instances. We looked at the Packer service to bake images. Now we kick off our brains, the control plane. And here's, I want to introduce function as a service. I used that term earlier, but I want to define it here. Function as a service is a mechanism where a substrate provider provides you certain languages, like in most popular in the Amazon and Google world, Node.js, Python, AWS has many other ways. It even supports Java to define your core logic. Don't worry about deployment. Don't worry about patching. Don't worry about all the other aspects which MC pointed about the limitations we had in our first party or on-premise infrastructure. And what they do is that they give you a runtime. So essentially, you go code your script and done with it, and that provides you that. That provides you the entire experience for the program. Now let's look at the control plane components once we decided that. So our control plane was composed of many of these cloud functions. We chose Node.js to do that. It was the most popular. Another interesting story here is that we had good expertise in writing Python applications, Java applications, and then we had to choose between Node.js and Python. Now, how do we make that call? So we realized we are jumping into this new platform. So we needed to see which of these languages were most mature. And we found out that in the Google Compute platform, it was Node.js. The second thing was, how easy was it for us and my team to get documentation? We are learning this tech, and we wanted to have great number of examples, great number of use cases to try at. And there's where we found a lot of documentation for Node.js. And finally, Node.js, we found that it was easy for us. The testability was really good for us if we were setting up web servers for the services we just talked about. So it helped us. So picking up that language defined the way we would use a tech forward. In our control plane, we have many components. One component like acquire environment would pick up an environment. Enrichment would then enrich data specific to the environment we want to build. Validate will run tests and do a cleanup. All these components talk to each other using the Cloud PubSub. So we used the asynchronous pattern, we used Node.js, and now we had different one function doing one action in the control plane. Now let's look at how did control plane provision resources? And there's where I would like to introduce Terraform. Terraform is another open source software from HashiCorp. It enables you to define your resources in the Terraform language. It's a consistent way to propagate that script across different platforms. It helps you do immutable deployments, and that's where I'm on a deep dive into a Terraform script. Next slide, please. So Terraform uses a Terraform configuration language. So Packer used a JSON, but Terraform configuration language looks like JSON, isn't a JSON. It's a format that Terraform understands. Terraform is built on. We use 0.11. There are many new versions that have come up right now. Again, this has sections, and the provider. The provider here is interesting because here you see it's a Google provider. If you had an AWS provider, then you could do it on Amazon and specific to other substrates. Resource has the resource specifics. The resource specifics being that it's a Google Compute instance here. It has what machine type, host name, zone, subnetwork. So this is all that information encoded here about the cloud resource. I want to highlight the metadata, the section in this Terraform script. This is super interesting for us. So you created a virtual machine, you install your app. How do you log in? Good, right? So we wanted to bootstrap some data, some user data into it. And this is how we use cloud init and the metadata section of the script to bootstrap that data to enable us to log in into the system. Now let's look at the Terraform service. The Terraform service, again, very similar to the Packer service, is a service that's hosted on a managed container service in the cloud substrate. It scales on demand. It enables us to provision resources as we need it. And I'll give you an analogy here. If a Packer image is a class, a Terraform environment is an instance. So we first built that representation through Packer. Hey, this is the cloud resource. Let's keep it to VM. We baked the image on the VM. The VM looks great. Now we actually run the VM. We actually run the test. So once Terraform service completes, it would signal back to the control plane through Cloud PubSub validate that, hey, I'm done. And you can run tests and do other actions. And there's where I would like to tie all of this together. So look at how we used to trace this entire pipeline. Next slide, please. So we used a very common technique for doing traceability. We used two very interesting unique identifiers, a trace ID and change number. So a commit ID could be a parallel to a change number. And the first part, the trace ID, is an alphanumeric key we used to generate. We would propagate this throughout the pipeline, from the ingestion from Packer service through Cloud PubSub and every message to the control plane, to the Terraform service, to the validate function. So what it enabled us? It enabled us to trace all these asynchronous processes in unison. We could see them through from start to finish. And the example there shows that, hey, I could actually walk the entire tree graph or a line just by following this trace. And that was a good way for us to be able to visualize our pipeline. Now let's look at how we tested and released this. Before that, let me summarize what we just talked about. What we talked about is, hey, we built two managed container services that were for Packer and Terraform. We could scale to 0 and n. We orchestrated all of this deployment using functional service cloud functions. And then we reconcile these workflows using communicating through messages and composing all of them through a cloud data store. So I want to deep dive there a little bit. We use the cloud data store to log every action. So first stage 1, stage 2, stage 3, stage 4. Why that's useful? Because pipeline logically is a sequence of steps, and we needed a way to compose this flow. And there's where we use the data store. So communication was through PubSub, and composing the pipeline was through the data store. Now let's look at how the test and release process. And we wanted to validate and run these things reliably. We wanted to make sure we had good quality pushing these changes. So in addition to how our app was getting deployed using Terraform and Packer and all those great tools, we decided that we would even push our code to cloud through Terraform. So all our cloud functions, all our container services, we would deploy using Terraform. That gave us a consistent way to push code so that we did not have surprises in deploying code. We also needed to iterate on the substrate many times for correctness, because certain things of functional service is only testable on the substrate. So that's one thing that I want to make the audience aware of, that it's really hard to test the real thing locally, because the substrate works very differently from how you would test locally. The container service was slightly easier because we exposed REST endpoints. We could run them in isolation. We could run them in CI/CD. Very well testable. But again, we had the risk of testing this end to end. And there's where what we ended up was to set up a parallel test stack. In this parallel test stack, what we do is that we deploy all the components. We do the same flow, like listen onto our upstream system, get the packages, bake and go through. Once we had good visibility around that, we would be able to ascertain if we were doing things correctly. Now let's look at the challenges. So what did we learn? I've been slowly I've been talking about those concepts in the past 7-8 slides, and I'll be explicit about it. It was very hard to visualize this run across asynchronous processes. So we needed to get very good at following traces, very good at working on the substrate to see how we can visualize this. There are microservices. Microservices are great. Yeah, I can break my functionality. You saw 3 big pieces, but really hard to run reliably, because all of them can fail. All of them can fail as a cascade. All of them can fail individually. And that's really hard to work with. And with scale, the testing evidence can only be gathered over number of runs, not in one shot. So what was important for us was that we had to build the dashboards and do some analysis to see correctness over a period of time. We couldn't just say that things were right just because we could have 3 or 4 good pipeline runs. Terraform provisioning actually works on hardware, or works on the cloud provider. And if there's a provisioning error, it's not auto-recoverable. So it was a big challenge for us to get that reliable, make sure that how we could handle Terraform errors. Here I want to take a pause and talk about a very interesting problem we had. So great architecture. We have cloud functions, these services that can talk to each other. They use PubSub to communicate with each other. So I have a great reliable way of getting these messages across. What we did not account for is that PubSub had at least one semantics, which means that maybe the Packer service finished, but it sent a message and the message is received by the cloud functions not once, but twice, or maybe 3 times. That would then kick off the pipeline 3 times, and that can break our workflow. So we learned this while testing, that we had to build a deduplication system where we could only consume message once and make sure that that could flow through. So at least one semantics was a big challenge for us to overcome, to make sure we had like one consistent run. And finally, cloud provider errors result in your platform errors. And that's really hard. It's really hard to debug. And if you've spent enough time with a cloud provider, you would know that at times the cloud provider errors, you might want to wait for the cloud provider errors to go away before you could actually debug your app. With that, I talked about the technical deep dive of our service. And at this point, I want to invite MC back to talk about our key takeaways, triumphs, and recommendations. Thank you.
Thanks, Tuhin. I hope it's very clear from Tuhin that how we built our architecture with all the tool sets we chose and why we chose, and importantly, how we orchestrated with all these tool sets to solve at scale problem that we had. And to just summarize, what some of the biggest wins for us with this for the last few years. It helped us to be able to repeat because of the immutable deployments. And also it's extensible, as you said, it's a synchronous process. You can always add more components into the workflow without disrupting anything. And importantly, now we can build on-demand capability with a kind of a well-defined access patterns and capacity we have with the public cloud. Another important win, this is very big for business, is the cost savings. With the on-demand, now we can bring up and tear down based on how many incoming code commits. If there's no code commits, like in midnight times and whatnot, then our infrastructure can scale to zero. Not only the representation, but all our cloud functions also can scale to zero. That's a huge cost savings for our run the business. And importantly, it also reduced triaging time when there's a failure happens, right? Now with the O-of-1 solution, we can point a particular commit as a problematic, and then we can tell the developer immediately. So there's no operations team need to involve in triaging and then waiting and then coordinating all this stuff. So that's all fully automated now. And with that comes a developer experience, right? Because now developers knows when they break, they get auto bugging. So that means now they are much more proactively make sure all integration tests, local integration tests they run, and then they calculate check-in. If not, then we will have any problem in the representation, we can quickly auto bug. So we can do a lot of better metrics for themselves to be aware of how well they're doing. So this is a huge win in terms of improving their own productivity and then through measures. The last one is a big thing also from operations point of view. If some reason developer not available to resolve the problem, then we have ability to do code commits. In fact, developers themselves sometimes work with the operations team to ask them to revert the code. Now we have that capability because of the architecture we built. So those are some of the big wins, and it helps solve our business goal. There's some key recommendations and takeaway I want you guys to walk out today is, as Tuhin mentioned, with asynchronous architecture, you really need to have a good testing strategy, right? Because you need to really stagger your rollout with your promotion functions with the different hops to make sure that issues like deduplication, all other things will never be a problem when you actually deploy in production. So having a very standard staggered rollout plan is very essential and need to be factored in your part of your deployment and rollout. Another important thing is with asynchronous architecture is if you don't have a well-built distributed tracing to troubleshoot particular pipeline failures, it is very hard, and you can spin the wheels with trying to find out where the actual problematic. So we factored that using the tracing technique that Tuhin shared with the two-field association. We use that to scale for say 500 commits an hour. You can still pinpoint which of the code commit which stage of pipeline they're broken. And that helped us to even sometimes troubleshoot quickly any public cloud provider errors versus our own platform errors. So having that will be very essential with this kind of scalable architecture to make it even operational excellence for your teams. So those are some of our learnings. I hope, as I promised in the initial of the discussion, that you would learn how we built our on-demand scalable architecture and some of our journey with us. So I hope you can take these takeaways and then help incorporate some of the useful things in your day-to-day projects. With that said, once again, I want to thank all of the audience for taking this opportunity and Andrea for giving us time to present this cool infrastructure that we built. So once again, thank you so much. With that, we're ready for Q&A.
Thank you so much, Mayakrishnan and Tuhin. I can totally do this. Now is a great time for questions. So if you have questions, let's go ahead and enter them either in Slack or in LoudSwarm. I've been watching the whole time. People, I think, were enthralled because they weren't asking questions. I think they were just trying to absorb because that was a lot of great information. And I'm waiting to see if any come through. So,
MC, do you want to share the survey?
Yes. How about you guys tell us how to do the survey?
Yeah, sure. Okay. So once again, thank you for listening to the presentation. So we highly encourage to provide feedback on our session. So the way you do that is you go to our homepage, Big Mountain Data and Dev conference page, and then you select the session and then the room you're going to land on our session. Once you're there, you can go in this left side navigation bar and choose the feedback page. And then once you click the feedback page, you would get a kind of a Google form. And in that form, you can fill in what session, and then you can provide your email address. And then there's a series of questions. I can promise you it shouldn't take more than 5 minutes max to fill in quickly. That will help us. Again, as I said, we are a learning culture, so that will help us to learn on some of your feedbacks, what's interesting, what is not, so that we can continue to improve this for the future presentations.
I can't tell you how valuable that feedback is for me when I've spoken, because there's things that I do that I don't realize that I do, and seeing that feedback helps me to go, oh yeah, I want to fix that, so I'm not obnoxious and doing bad habits as I go forward. The other thing is that it helps me to better tune my presentation for the next audience, so you're helping people down the road. So it's awesome and super, super needed. Oh, we do have a question. They want the GitHub link again. Can you post the GitHub link again?
Yeah, I'm going to post it on the Slack channel. Is that okay?
Perfect. That's perfect. And I can copy that over and paste it over into the Slido as well.
Okay, I'll just do that right now on the room one. This is for Packer. And the next one is Terraform. I'm doing that right now, but yeah, if you have other questions.
Let's see if we have any other ones. Not so far. Oh, there's the Terraform one. So I'm posting both of those into Slido right now.
Sure.
So Andrea, so also part of this, they'll also get access to the slide deck, or how does it?
So there is a recording that is going to be available of this session, so people can go back and watch the entire recording. I know that I like to go back and rewatch recordings. It's going to be on the Utah Geek Events YouTube site, and I can go ahead and post a link to that in Slack if people would like to see that.
Great. Thank you.
Yeah, and so that should be up in the next few days. All right. Do we have any other questions before we let these awesome gentlemen go? We really appreciate your time today. It's been so fantastic. I think we're good.
Oh, thanks,
yeah, with that, we really want to thank you for your time. We appreciate you giving us this opportunity to present in front of you. And we have a social network links on the presentation, so please reach out if you have any further questions and if you would like to learn more. Thanks from me.
Yeah, once again, thanks from me also. As I said, right, if you have any other questions, we are always available offline. Yeah, as you watch the video, you will have the LinkedIn link or any other social media way we can also.
Awesome. Thanks, everybody. Have a great day.